partial derivative, I can convert it to the partial derivative, exact derivative. And suppose, and my this one is, take positive sign, ds minus rho g into dz. This positive, this one is go to the right side, so rho into ds. And A is acceleration, I can write local acceleration and convective local acceleration equal to dv by dt. So suppose the flow is, velocity is v, and this is the convective dv by ds. I already suppose ax equal to u into du by dx, v into du by dy, and w equal to du by dz into du by dt. This one is convective acceleration, this is the local acceleration. I put here v into dv into ds. V is the, suppose this is the cylindrical elements of fluids, and this is the streamline direction s. So s direction, the velocity is v, and this is the length of the element ds. So I can write v into dv into ds. The flow is that s direction, so this is the direction, this dx is the direction. Here direction is along x, along s, so I have ds. Understand? And wipe this one. Now here the flow is steady. Flow is steady. Steady means velocity with respect to time is 0. dv into dv by d is 0. So this one is 0. So dp into ds rho g into dz plus rho into ds into v dv by delta s. So convert this the partial derivative into exact derivative. This is the partial, convert this one, ds into ds plus rho g dz plus rho into ds into v into dv by ds equal to 0. This one cancel out and this one cancel out, and here this is the compressible, steady and compressible. So rho value is d into rho into this one v into dv plus d into dz equal to 0. This is the Euler Euler's equation of motion. Euler equation of motion. This is very, very important. So assumptions for Euler equation. Number one, the flow is ideal. That is viscosity is zero. Number two, the flow is steady. Number three, the flow is compressible. Fluid is ideal. Sorry. Rho is ideal. Fluid is ideal. Sorry. Flow is incompressible. Number four is the flow is one-dimensional. Number five is the flow is laminar or streamline flow. Now we know for Euler equation of resulting net force equal to gravitational force in x direction and pressure force is x direction, and Fv, Ft and Fc are negligible. So ideal is no viscosity. Here Fv is negligible. Flow is steady, means velocity with respect to time is zero. Flow is incompressible, rho is constant. Flow is one-dimensional and streamline flow. Incompressible means force due to compressibility equal to negligible. Is negligible. And Fv and turbulence means laminar, so Ft is negligible. You didn't remember it. You can't remember the assumption for Euler equation of motion from this equation. Fv is negligible, means no viscosity, so the fluid is ideal. Force due to turbulence, so no turbulence flow, so the flow is laminar. And Fc, force due to compressibility, so force due to compressibility is negligible, so this is incompressible flow. Incompressible flow means rho is constant, density is constant. And flow, I already assume the flow is steady. You can remember, and this is one-dimensional. Now Bernoulli equation from Bernoulli's equation obtained by integrating Euler's equation by integrating Euler's equation of motion. So Euler equation is dp by rho v into dv plus g into dA equal to 0, and integration p into rho into v square into 2 plus d into z equal to constant, and you can write it p into rho g v square by 2g plus j equal to g value is 9.81 meter second square. So g is divided by c, so this value is also constant. This is the Bernoulli's equation for a streamline, for a streamline. This is the constant value. For these points is very important. For in rotational flow, in case of rotational flow, Bernoulli's equation is applicable for along the streamline, because of C is different for different streamline. C is the value of C. The value of C is different. Value of C difference for different streamline. This is different for different streamline. In case of, suppose this is a pipe, this is the pipe, this is another streamline, this is another streamline, and take a section. This is 1, this is 2. In case of irrotational flow, Bernoulli's equation is applicable between two sections. between two section, between two section, because C is same, the value of C or C is same for entire section, for entire section. Means, so this is section A, this is section B. For section A and section B, the Bernoulli's equation value is C same for entire section. So I can write rho G, P into rho G into V1 square plus Z1 equal to P2 by rho G into V2 square by 2G plus Z2. This is the, so from here you understand the flow must be irrotational for Bernoulli's equation. Understands? So the assumption, these are very important exam point of view. Assumption for Bernoulli's equation. Number one, the fluid is ideal. Means viscous, the flow is steady. Number three, the flow is incompressible. Number four, the flow is irrotation. The flow is rotational. Understands? This four is very, very important. Now suppose this is a pipe or two dipper, and this is suppose this is the height, this is a datum line, this is section 2, this is section 1, and this is Z2, this is Z1. Understand? Here, so Bernoulli's equation between two section, P1 into rho G, V1 square by 2G plus Z1 equal to P2 by rho G plus V2 square by 2G plus Z02. This is the Bernoulli's equation between two sections. This P by rho G, and for a streamline the equation is P into rho G, V by 2G plus Z equal to constant C. Suppose this number 1, this is number 2, and this is number 3. Here number 1, this is the pressure force, or you can say this one work work required to maintain flow, or pressure force per unit weight. Pressure force per unit weight, or pressure head, Suppose this is the suppose this is the dA and pressure P is and the displacement delta x. After pressure P acting on this portion and displace delta x, so force required to maintain the flow F into A, and work required equal to force into A into displacement. So from here you can write the pressure force. This is the pressure force. Pressure energy. This is pressure force, not pressure energy. Pressure energy. This is the to work required maintain flow per unit weight. Understand? So work done required to maintain flow. This is work done, and weight equal to rho into G. Now volume A into delta x. So this is the work and weight. So work by weight. So pressure head. You can write pressure head